right, so we're taking a look at these hydrogen bonding problems from our Michigan State virtual textbook link. And first of all, why are we looking at these problems? Well, these are good problems because this gives us practice identifying something that's very important for organic chemistry, and that is this concept of hydrogen bonding. So our focus here is very limited, just to 3 elements. So our focus is always limited to very few elements in organic chemistry. But as far as the hydrogen bonding, we are looking at situations where hydrogen is bonded to one of 3 elements: nitrogen, oxygen, or fluorine. And so we're provided here with a set of choices, and we're asked information about the hydrogen bonding accepting and donating ability of these molecules. Some will have both, some will have neither. What we'd like to be able to do is just, given a lineup of molecules, pick out ones that have hydrogen bonding and the ones that don't. In this case, we're asked to take it a step further and not only identify hydrogen bonding, but identify molecules that act as hydrogen bond acceptors. Well, if we just think about what is hydrogen bonding, and if we take the example of the simplest situation, just take hydrofluoric acid. Now, we're provided Kekule structures in this set of problems, and the only difference between that and a Lewis dot structure is the dots. And so I've drawn hydrofluoric acid using the complete Lewis dot structure. And we can identify one important element of the bond here, and that is it is highly polarized. It's hydrogen bonded to the most electronegative element on the periodic table. So we know that our polarity lies such that the very electronegative fluorine atom is going to be hoarding most of the electron density in that bond. So what we'd like to do is identify the characteristic of this molecule as being both a hydrogen bonding acceptor and a hydrogen bonding donor. The donating ability of this comes from the fact that we can set this molecule next to another molecule of HF, and there will be a strong hydrogen bonding interaction between the lone pair of that fluorine atom and this highly polarized hydrogen fluorine bond. So the positive character of that hydrogen lends itself to forming this very strong interaction with the lone pair of the fluorine of the adjacent hydrogen fluoride molecule.